So we are going to look at the addressing modes of 8051 microcontrollers. So basically CPU usually access data in various ways. This data can be found in the register, they can be found in the memory, or they can be given as an immediate value. These various ways of accessing data by the CPU are what we refer to as the addressing modes. And therefore, there are various addressing modes, and these ones are always determined, and also they're always determined, and therefore, they cannot be changed by the programmer. So, when you talk of the 8051 microcontroller, 8051 microcontroller usually provide a total of 8 distinct addressing modes. The total of 8 distinct addressing modes. These ones are as follows. So we have 8 distinct addressing modes. We have what we call the register addressing mode. The second one, we can also have what we call the direct addressing mode. Direct. We can also have indirect. We also have immediate. We also have relative. Sixth one, absolute. Seventh, we have long. And also, finally, 8, we have indexed addressing. So when you talk about this particular addressing modes, the first 4 are the most common ones. While I'm not saying that the last 4 are not important, but the first 4 are the most commonly used addressing modes, and they're always very, very discernible from what we have. So when you talk of, we are going to look at the first one, which is the register addressing. The first one, we can talk about register addressing. Some people usually refer to it as register addressing mode. So when you talk of the register addressing mode, then this one usually involves use of registers. Whenever you see an instruction that involves use of registers to hold data that is supposed to be manipulated, that one we talk of the registers as we talked about the register, that is the register from R0 up to R7. R0 to R7. If they are used, if these are where the data is supposed to be the data to be manipulated is stored, then this is usually referred to as the register addressing. So the instruction using the register addressing are usually encoded just as follows. So you can talk of examples of this. You can see that we have move maybe A, R0. That is to say that copy contents of R0 into A. Copy contents of R0 into A. So in this case, we are talking about A being a register and R0 also being a register. So in that case, you can see that this particular instruction only involves registers. So therefore, the information is taken from the register and it is taken to the register. The source is the register R0 and the destination is the register A. So in that case, that is how it's supposed to be. You can also have other instructions like add A, R5. You can also have add A, R5. That is also register addressing mode, and so on and so forth. You can also have something like move DPTR for the data pointer, then that 25F5H, that is also a register, and because this one is a 16-bit register, so this one is also 16-bit. Or you can break them into 2 so that you can talk of move what is in R7, into DPL, that is the data pointer low, or move what is in R6 into DPH. So all that are what we refer to as the register addressing modes. The second one that we can talk about is what we refer to as the direct addressing. the direct addressing. Direct addressing. Number 2, we can talk of direct addressing. Direct addressing. So when you talk about the direct addressing, then from the earlier discussion, we said that there are 128 bytes of RAM in 8051. And these ones are the memory locations whereby we usually have the data. The data can be stored in this case. So we can simply say that in direct addressing, we are talking about the access of any memory chip location. Like, for example, I can have an instruction like add A, 55H. Add A, 55H, which means as opposed to, you will notice that there is a difference. If I say add A, then pound sign 55H, then it means that the 55H is the data itself. But if I omit this, if I omit the pound sign, then what it means is that 55H is now a memory location. So in this case, when we talk about the direct addressing, then we are talking about movement of data that is stored in a given memory location. For example, you can talk of move R0, 40H, that is also, or you can talk of move 56H, A, or you can also talk of move R4, 7FH. So those ones are other examples of direct addressing mode. So the direct addressing mode simply means that we are able to access the memory location, and then it is from that particular memory location where the data is stored. So that is what we refer to as the memory. Or you can also have another instruction like this. This one can also be there, like move P1, A. So you can see that this P1 is port 1, and it is actually a memory location, and it is always addressed. For example, you'll find that port 1 is addressed maybe 90H as its memory location. So in that case, this one also can be considered under direct addressing, because the port 1 will be given a certain memory location, and that one is where it will be addressed. The next the next addressing mode that we can talk about, that is the third one, is what we refer to as the register indirect, or we can simply refer to it as indirect addressing. Indirect addressing, or register indirect. Indirect addressing, some people usually refer to it as register indirect. So in this method can be used when to identify a variable and also its address, and it's always determined or modified when the program is running. So in this case, the 8051 usually use the two registers, that is the register R0 or R1 for that particular purpose. And these registers may act as a pointer, and their content indicates an address in internal RAM where the data is supposed to be written or read. For example, you can talk of an instruction like you talk of move A, at R0. So in most cases, in 8051 assembly language, indirect addressing is always represented by an at before either register R1 or register R0. So that is how indirect addressing is supposed to be. So anytime you see an at preceding register R1 or register R0, then it means that the register, either of the registers, is just pointing at a certain memory location where the data to be manipulated is. And in that case, if you have an instruction like this, then it means that it is supposed to move a byte of data from an internal RAM at a location whose address is in R0 to the accumulator. So that one means that it is not now register R0, but the register R0 acts as a pointer to an address in the memory location where the data to be manipulated is found. The fourth addressing mode that we can talk about is the immediate addressing mode. Immediate addressing mode. Immediate addressing mode. So when you talk about the immediate addressing mode, this is what we have been using all along. It is always preceded by a pound sign. So, and it happens when the source operand is a constant. So when you talk of immediate addressing mode, immediate addressing mode. So when the source operand is a constant rather than a variable, then the constant can be incorporated into the instruction as a byte of immediate address. So in assembly language, the immediate operands are always preceded by this sign, that is the pound sign. So anytime that pound sign precedes a given number, then it means that that particular type of addressing is what we refer to as immediate addressing. And in most cases, the operand can always be a numeric constant, or it can be a symbolic variable, or an arithmetic expression that uses constant, symbols, and operators. The assembler computes the value and substitutes the immediate data into the instructions. For example, you can have an instruction like this, where you can talk of move A, comma, pound sign, 12H. So this instruction simply means that you are moving the immediate data, 12H, into register A. All these immediate addressing mode usually use 8 bits of data with one exception. Like you can talk of another one. This is the exception. You can talk of move DPTR, comma, pound sign 8000H. So that one, it's a little bit bigger. So it is not going to be 8 bit of data, but rather 16 bit of data. So anytime you have a pound sign preceding a number or a constant value, then that one can be considered to be immediate addressing mode. So we can look at the fifth one, that is the relative addressing. Relative addressing. Relative addressing. So relative addressing is always used with a certain jump instructions, and where the relative, which is an offset, is an 8-bit signed value, and it is always between minus 128 to 127, which is added to the program counter to form the address of the next instruction. And prior to this addition, the program counter is incremented to the address following the jump, which is now the new address, which is the relative to the instruction and not the address of the jump instruction. However, the details of relative addressing, these details are not always of concern to the user, since the jump instructions are usually specified as labels, and the assembler determines the relative offset by itself. The main advantage of this particular relative addressing is that it has got what we refer to as the position dependent codes. So that is what the relative addressing is all about. So we can talk about the next one, which is absolute addressing. Absolute addressing. So when you talk about absolute addressing, then the absolute addressing, when you talk about the absolute addressing, it is always used with two basic instructions: absolute call, ACALL, and AJump. So those ones are they represent ACALL and AJump, and the last significant bits of the destination address usually comes from the opcode, and the upper 5 bits are usually the current upper 5 bits in the program counter. The destination is also the same, that is the 2K of the source. So that is what this one is all about. So the next one, you can talk of the long addressing. Again, long addressing usually has basically two instructions. So when you talk about long addressing, they usually have basically two instructions: long call, L call, or LJMP. And the 3 bytes instruction usually include full 16-bit destination address as bytes 2 and 3. Then the last one that we can talk about is the indexed addressing. So in most cases, the indexed addressing, at times it looks like indirect in some way, but now the difference is that it usually has it usually uses either a data pointer or a program counter, and then the accumulator that is used as an offset. For example, you can have an instruction like move code, so that is indexed addressing. You can have an instruction like move code A, comma, at A plus BPTR. So this instruction is used in order to move a byte of data from, it moves a byte of data from code memory to the accumulator. And the address in the code is found by adding the accumulator to the data pointer. So basically, when you talk of the index addressing, it uses a base register. And this base register is either a data pointer register or a program counter. And an offset is always the accumulator in order to form the effective address for the jump or move code instruction. So it is always used for the move code instruction or a jump instruction. So those ones are the 8 addressing modes of the 8051 microcontrollers. So we can look at the instruction types. So basically, when you talk about the instruction types of 8051, they are divided among 5 groups. The first one is what we call the arithmetic instructions. We can also have logical instructions and also data transfer. We can also have what we refer to as the Boolean variable. Then program branching. So those ones are the instruction types as far as 8051 is concerned. So we are going to look at the instruction types that talks about the arithmetic types, the arithmetic instructions. So when you talk about the arithmetic instructions, then we can look at them also based on the different addressing modes that are available. Arithmetic instructions may be written as, maybe you can talk of an instruction like add A, 7FH. Like in that case, if you look at that, then this one is direct addressing, because that is now what we have. We can also have an instruction like add A, at R0. So that is register indirect or simply indirect addressing. We can also have an instruction like add A, R7. So in that case, that is register addressing mode. And then you can also have add A, that 35H, that is immediate addressing. So all the arithmetic instructions are always executed in one machine cycle, except some 2 instructions, except these, no, not 2 instructions, but instructions that include incrementing data pointer, that is inc dptr, We can also have an instruction. This one has got 2 cycles. That one has got 2 cycles. Or another instruction we can talk about an instruction like multiply AB and divide AB. Mul AB and div AB. And these instructions, both of them have 4 cycles. 4 cycles. Both of them have got 4 cycles. So that one is what we can talk about. So arithmetic instructions. These ones usually you can talk of subtract, you can talk of add and divide, multiply. So all those are always referred to as arithmetic instructions. The next that we can talk about is what we call the logical instructions. Logical instructions. So when you talk about the logical instructions, these ones are supposed to perform, these are instructions that are supposed to perform Boolean operations or Boolean operations on data on a bit-by-bit basis. For example, the different modes of operation, the different modes for logical instructions we can have ANL, A, comma, 55H, that is for direct, ANL, A, comma, at R0, that is for indirect, ANL, comma, ANL, A, comma, R6, that is for register, then ANL, A, comma, #33H for immediate. So those ones represent logical instructions, and all other logical instructions, logical symbols that can be used. You can talk of things like RLA, you can talk of, and there are several logical instructions. Then the next one is the data transfer instructions. And the data transfer instructions, we can divide them into 2. We can talk of both internal. The first one is internal. And internal, especially for data transfer instructions, we can talk of internal. So the third one is data transfer. Data transfer instructions, where we can talk of we can talk about internal data transfer. And this one can be represented by move, then destination, move, destination, and then comma, then source. So that is an example of internal. And this one usually allows data to be transferred between any 2 internal RAM or special function registers locations. And also, you can also add to that the stack operations, that is pushing and popping. That is what usually happen in stack operations. They are also internal data transfer. So another one that we can also talk about is exchange, that is XCH. Another data transfer, you can talk of XCHA, comma, source, then this one means that you are causing the accumulator and the address byte to exchange data. So you can cause that in order to exchange data. You can also talk about data transfer internal. We talked about internal, so we can talk about external data transfer. So when you talk about external data transfer, then we are simply talking about the external data transfer is now the data transfer instructions that move between the internal and external memory. And this one usually used in direct addressing. You can use indirect addressing, and for that purpose, the address could only be 1 byte, and it should be residing in either R0 or R1, or 2 bytes that resides into data pointer. For example, you can talk of move. You can talk of instruction like move dptr, data pointer, comma, that one, 10f4h. So that one can be a good example of that. You can also talk of move x. You can also talk of an instruction like move x a, comma, at dptr. So those ones are some. You can also talk of move codes, that is move C. You can also talk of move C. We have move code, which loads the accumulator with a byte or from code memory, that is from the program memory. And the address of the byte is the sum of the original 8-bit content of the content and the content of the 16-bit. And this one is either from the data pointer or the PC, that is the program counter register. So those ones are some of the data transfer instructions. We can talk about the next one. We can talk about the Boolean instructions. And the Boolean instructions usually contain, so that is the fourth one, the Boolean instructions. Boolean instructions. Boolean instructions. So usually contains a complete Boolean processor for single bit operations, and all bit accesses use direct addressing. These bits may be set or cleared in a single instruction. So for example, you can talk of set B, P1.7, or you can talk of CLR, that is clear, P1.7. Other examples can be clear C. You can talk of CLRC. You can also talk of CLRCY. So those ones are some of the Boolean instructions that can be used. The next data type is the branching instructions. And the branching instructions, we usually talk, there are three versions of jump instructions. So branching instructions, we can talk of the three versions of jump instructions. That is the short jump. This instruction, it is an instruction of 2 bytes and jump a distance that is limited to minus 128 to positive 127. We also have long jump that specifies the destination address as a 16-bit constant. The destination address can be anywhere in the 64K program memory space. And then we have absolute jump that specifies the destination address in 11-bit constant destination and must be within 2K block of a jump. So in all these cases of jump, the programmer specifies the destination to the assembler, and this one is done by use of the label or a 16-bit constant, and then the assembler puts the address, the assembler will put the destination address into the correct format. Another instruction you can talk of is subroutines and interrupts. So when you talk of the subroutines, then the subroutines usually have what we call instructions. So we have call, and these calls can be, we can either have the normal call, or we can have absolute call, which we refer to as A call, or long call, which is L call, using either absolute and long addressing. The generic call may be used if the computer does not care which way the address is supposed to be coded, and either of these usually pushes the contents of the PC, the contents of the program counter into the stack and loads the PC with the address that is specified in the instruction. So then another one that we can also talk about is the conditional jump. The conditional jump still under branching instruction, and you can have several types of jumps. We have JZ, jump if 0, and JNZ, jump if not 0, which tests the accumulator for a particular condition. We also have DJNZ, that is decrement and jump if not 0, and it is always useful instruction for building loops. For example, to execute a loop n times, you are supposed to load the register with n and terminate the loop with DA, J, and Z to the beginning of the loop. Then we also have another jump, which usually refer to as CJNE, that is compare and jump if not equal, is another conditional jump instruction. It is 2 byte, and if the first number is less than the second one, then it will always set the carry flag. And that is, those ones are some of the instruction types that are found in 8051 microcontroller.